Hi guys, this is the final lesson for Module 6 and we're going to be modeling with our linear system. So we're going to look at some scenarios that we can write a system of equations to model and then use that system to solve, and we can use either of our methods. We could use graphing, substitution, or elimination. Okay, so here's kind of our steps. We want to first define our variables and then use those variables in our two equations for our system. Okay, so in our first problem here, you are decorating for prom and you're in charge of buying balloons. You want to use both latex and mylar balloons. The latex costs 10 cents each and the mylar costs 50 cents each. You need 125 balloons total and you have $32.50 to spend. How much of each should you buy? So we want to come to the last sentence here to help us with the variables. How much of each type of balloon, if I were to kind of plug that in, is what this is asking. How many of each type of balloon should you buy? So we need our variables to represent each type of balloon. That's what we're trying to find. So I'm going to use L for latex balloons. And I'm going to use, if I could spell balloons, there we go. And I'm going to use M for mylar balloons. Okay, so that last sentence kind of tells me what I'm looking for and what I should make my variables be. So one of the equations should deal with the cost and one should deal with the total number of balloons. So this is really common in system of equation word problems. One is going to deal with the total number and the other is going to deal with cost. Really, really familiar. Okay, so the number of latex balloons and the number of mylar balloons total should add up to 125 because that's how many balloons we need. So latex plus mylar has to equal 125 balloons. So that's talking about the number of balloons. Now we are going to involve the price as well. So each latex balloon costs 10 cents. So however many latex, I need to multiply that by 10 cents to figure out the price there. Mylar is 50 cents each. So we're going to multiply the number of mylar balloons times 50 cents. And since this is dealing with price, what it should equal should also be dealing with price. So we have $32.50 is the total. Okay, and we can use any of our methods to solve. So personally, I like substitution a lot, but you guys can use whichever one you want. So I'm going to solve one of these for L or for M. So I'm going to solve for L. So I'm going to get L by itself, and I'm going to subtract M from both sides. So I have L equals 125 minus M. So I'm going to take this, and I'm going to substitute it in for L in the other equation. So now I have 0.10 times, instead of L, we're replacing it with 125 minus M, plus 0.50 M equals 32.50. Okay, so I'm taking that 0.10 and multiplying, distributing. So 0.1 times 125 gives me 12.5 minus 0.10 M plus 0.5 M equals 32.50. All right, so now I'm going to combine like terms. So I have, come back up here. So I have 12.5 plus 0.4 M, so that's what happens when I combine negative 0.1 and 0.5, equals 32.50. So now I'm subtracting 12.5. So I have 0.4 M equals 20 divided by 0.4. So M equals 50. So M was the number of mylar balloons. So to figure out the number of latex balloons, we could plug 50 in back here. So I have L plus 50 equals 125. So if I subtract 50 from 125, I get L is 75. So our final answer is 50, if I got room here, 50 mylar balloons. Oh, and sorry, you guys can't see that. 50 mylar balloons, 75 latex. All right, I'm going to zoom out just a hair so we can see all of that. There we go. Okay, going on to number 2. For 30 minutes, you do a combination of walking and jogging, At the end of your workout, the pedometer displays a total of 2.5 miles. You know that you walk 0.05 miles a minute and jog 0.1 miles per minute. How many minutes were you walking and jogging? So again, last sentence tells us how to define our variable. So we want how many minutes we're walking and how many minutes we're jogging. So I'm going to use W for walking and J for jogging. Okay, so we don't have a cost involving this one, but it's still going to be very similar. We're going to have the total number of miles walked, and then we're also going to have the speed. Okay, so those are kind of the two different things we're talking about here. We're talking about distance and speed. Okay, and I guess kind of time in there as well. So we're doing 30 minutes. Okay, so the minutes walked and the minutes jogged have to add up to be 30 minutes. That's how much time is spent walking and jogging. Now, how much on each one? Well, that's where the speed and miles per minute comes. Okay, so walking is 0.05 miles per minute. So if I multiply that by the number of minutes walked, that would tell me how far. Same with jogging. This is 0.1 miles per minute, and that is equal to 2.5 miles. So this involves the distance, and then this involves the time. So kind of correlating those two pieces together. All right, and again, you can solve using any method. I personally like substitution, so again, I'm going to rewrite that equation as W equals 30 minus J, and I'm going to plug this in for W. So I have 0.05 times 30 minus J plus 0.1J equals 2.5. Distribute that 0.05 there. So we have 0.05 times 30 is 1.5 minus J plus 0.1J equals 2.5. All right, so this is a 1, so like -1 and 0.1 becomes -0.9. Subtract 1.5. Oh, I distributed that incorrectly, you guys. I'm sorry. -0.05 times J is -0.05J. All right, let's try that again. So I'm doing -0.05 plus 0.1. So that's what I get when I combine those like ones. There we go. Okay, so now I'm going to subtract 1.5 from both sides. So I now have 0.05J equals 1 divided by 0.05. So J is equal to 20. So J was the number of minutes spent jogging. W is the number of minutes spent walking. So W plus J had to equal 30. So if J was 20, W has to be 10. So 10 minutes walking and 20 minutes jogging. It's pretty good. I would definitely be the other way around. So, all right. Number 3. Okay, your portable stereo requires size D batteries. You have $25 to spend on 5 packages of 2 batteries each, and you'd like to maximize your battery power. Each regular package of batteries costs $4.25, and each alkaline package of batteries costs $5.5. I'm guessing that's supposed to be a 0, but $5.50? Because alkaline batteries last longer. How many packages of each type of battery should you buy? All right, so we need 5 packages total. So we have our regular packages, so I'm going to use R for regular, and we have A for alkaline. So total, I'm going to buy 5 packages. So I need the number of regular plus the number of alkaline to equal 5. All right, so we have each regular is $4.25, so $4.25 R. Alkaline, I think that's the right number, is $5.50. And that should equal our total costs of $25. All right, so again, I'm going to do substitution here, you guys. So I'm going to say R equals 5 minus A. Take that, substitute in for R. Distribute. So I have 425 times 5 is 21.25 minus 4.25A plus 550A equals 25. All right, so combine these like terms here. So I have negative 4.25 and I'm adding 5.5. So we get 21.25 plus 1.25A equals 25. Subtract 21.25 from both sides. So we are left with 1.25A equals 375. And I think that does work out well, so that means I picked the right number. 3.75 divided by 1.25 is 3. So if they bought 3 packages of alkaline, that means they bought 2 packages of regular. So 2 regular and 3 alkaline. Alright guys, there are 3 examples on setting up a system to solve word problems. Thanks for watching.